Okay, so let's create our tables now. I'm just going to zoom in a bit for the screen. We're going to create table, and let's start by, for example, creating the character table. All right. You'll notice that characters in blue, normally when we put a table name here, we get black text. That's just a coloring thing with IntelliSense, because character, in addition to being our table name, is also a keyword used in the database. So it's just sort of highlighting the word in a color, and don't worry, it doesn't break the way it works. It's just a color. So for our character, let's put in all these fields here. I'm just going to copy in the first two columns and paste them. Put a comma after each of the definitions. And now you've got column definitions consisting of a column name, a data type, and in some cases things like identity, not null, and so on. Player ID and class ID are going to be not null, so let's throw those in with our column definition, so not null. Same thing here. All right. Our create date, it's the day that the character record was created. Well, let's put in default of current timestamp. Okay, that just means that when the character record is created, it will automatically have a default of whatever time it is that the record was created. And I think I'll also make the character name not null, just to make it required. And now let's make sure that our documentation reflects that. So I've got not null on character name, a default of current timestamp, all my constraints here, and I've already got those not nulls there. We could go ahead and make all these fields required, give them all defaults. I'm going to stop there for now. Constraint, pk character, char ID. So that's our naming convention again. We're going to create a primary key for every one of our tables. Whether it's parent or child, it always has a primary key. Now we've also got these two foreign keys to deal with. So let's put a comma after our primary key and start typing. Constraint fk character, and then for our foreign keys, the third part here says which table are we pointing at with our foreign key. So we'll do this one first here, this player ID. So we're going to point to the player table, and we're going to make it a foreign key on our player ID field. Now the next part of our foreign key is that we have to put in what table it references, and it references the player table on its player ID. But we have a problem. And the problem is that we cannot create this particular, I'm just going to expand this a bit. We cannot create this particular foreign key until the player table exists. If I were to try to run this right now, I would get errors. I've already got IntelliSense hinting at me that I'm going to get errors if I try to run things. So what I need to do is make sure that my player table is created first. And even if it is created first, I have to make sure that it has the player ID column in there. At this point, we're still getting an error down here saying that there are no primary or candidate keys. That's because we haven't made a constraint for this yet. PK player, player ID, primary key, player ID. So just to show that this will now work, if I have a player table and then I have the create table run for the character table, everything runs just fine. Problem is that now let's refresh our tables and have a look. Player table only has the one column, and we want a few more columns in there. So let's try to drop the player table. I'll do this in a new window just so it's really clear what we're doing here, but I'm going to go drop table player. Okay. IntelliSense doesn't really have a problem with it once I refresh my local cache, so edit IntelliSense refresh local cache. Alright, I'm going to drop the player table. Oh wait, no I'm not. It says could not drop object player because it's referenced by a foreign key constraint. What that means is that this foreign key here that we created that says this table, this character table references the player table, prevents us from dropping the player table. The only way we can drop the player table is if we get rid of that foreign key. And for us, that means we're going to have to drop the character table first. And again, that blue coloring is not a bug of any kind. It's just the way that our code coloring is meant to work in SQL Server. You can put square brackets around it if you really like, if you really need to get rid of that. It's all good though. I mean, the square brackets are just an optional syntax. You don't need them there. The drop table character will work even if the lettering is in blue. So I'm going to drop character, commands completed successfully. Now I'm going to drop player, same idea. So I cannot drop a parent table until I've deleted the child first. So I'm going to refresh here, edit IntelliSense refresh local cache, and that'll fix all those extra red lines that said that the object already existed. And I'm going to quickly, like magic, finish the create table player statement. Very quick. Okay, so just like before, column definitions. So I've got the name, I've got the data type, and a comma. I might want to put not null for some things, like for the first name and last name. And I'm going to do that, and then I just have to make sure that my documentation is updated with the same thing. I need a not null on my email as well, because email is the way that people are going to log into my game. And I'm good to go. I've got player, I've got character. One problem is we've got this class ID here for the character table, but we haven't defined a foreign key for it. What that means is all we have is an integer field that has to have a value in it, but we're not restricted to using values that are in the class table. In fact, we haven't created the class table yet. So let's create another constraint here, and here's a cool thing. I can just copy and paste my previous constraint and then change up the things that are necessary here. So I'm going to go comma, and I'm going to paste that foreign key down, but this time I'm going to be using the class ID field from this table, and then I'm going to be referencing the class table and its class ID. Right. I can't use the same foreign key name. I have to make sure, because it's two different things with the same name, the database system won't know how to deal with it otherwise. I'm going to go class to say the other table I'm referencing is class. Now, if I try to run create table character, let's just refresh my table so we don't get confused here, but if I try to create this, it won't work because foreign key on player references an invalid table. So I can create the player table, and then I try to run the create table character statement. I get a new error that says it references an invalid table named class. So let's create our class table. Create table class. It has a class ID, which is an integer, which is an identity field. And it has a class name, which is a variable character field. And I set that size to 20. And then we have a primary key we need on every table. All set. Now if I create the class table, I'm good. And then I can create the character table. If I refresh my tables, all three of them exist now. So I've got a player who can have many characters, and a character who can belong to a player and also belong to a class, and a class that can have many characters, or many characters can be part of a class. So that's that there. Create table player, create table class, create table character.